At this point in time, our assembly contains the subassembly of the shock that we created, and it contains our dog bone linkage. Now, these are both components that were created external to the assembly. They're their own files, their own parts, and we inserted those components directly into the assembly as a subassembly or as a component. There's another thing that we have called an in-context part. Now, when you're designing parts in SOLIDWORKS, there are a few different workflows that you can handle. The shock was created using a multi-body workflow, which means both components, even though they were meant to be an assembly, even though they were meant to move, were created in a single part file, broken out into their own part files, and then brought back into an assembly. Now, that's very powerful because what we can do is we can modify the original part file and it'll all trickle down out to those individual part files and back into the assembly. The benefit of that is if we modify the individual assembly or the individual part files, it doesn't go back to the original multibody file. So it's a one-way workflow. There's something inside of an assembly called top-down or bottom-up design. When you do a top-down design or an in-context design, you're creating components inside of your assembly that are based on other components. This means that it directly relates to geometry of other things, whether it's hole locations, edges, certain geometry. That all happens by relating those components inside of your assembly. Now, what I mean is you can go to your Insert Components dropdown and create a new part. And that's exactly what we're going to do here. We're going to create the linkage that goes between this, the swing arm, and our shock directly inside of our assembly file. So we'll go to Insert Components and go down to New Part. Now, the first thing that we need to do when we're creating a new part is select where we want to place it. And this is a very delicate operation. If you select one of your components, for instance, a bottom face of the shock body or a bottom face of the linkage, you are creating a relation between the linkage and the new component. And that's very dangerous, especially when you have components that move. If the components are always fixed together, that's fine. You're essentially creating an in-place mate and you're bringing that geometry in. What I want to do is I want to select some of the planes that are directly in the assembly file. They have absolutely nothing to do with the components in the assembly, but they have everything to do with the assembly itself. So I'm going to start by placing the front plane as my first plane of creation for my in-context part. Now inside here, it directly pops us into a sketch and we need to start sketching. And again, you want to be very careful about geometry that you're referencing. If we're going to reference components like the bottom hole of the shock or the hole of this linkage, when these move together, our component's going to change. And I'm going to show you an example of that. So we're going to start a new file and I'm going to put a circle at the origin. I'm going to dimension it to 50 millimeters. And then I'm going to bring this edge by using convert entities. I'm then going to place a line between the two and we're going to say okay. Now, I'm not going to modify the sketch at all. I'm not going to create any solid geometry, but I'm going to go back into the assembly. The reason this is important is because what I've done is I've created a relation between this component and this component. Now, when I move this, you notice that this sketch sort of stays in place. When I rebuild, it pops back to that location. So this is a very dangerous methodology because if we're creating a linkage that's supposed to be rigid between this point, and this point, obviously it gets real tricky if you start relating to that geometry. So this is one of the very big downfalls that I see new users make when they start creating these components in an assembly. I highly recommend that you start by creating your individual part files as a multi-body or as their own individual part files, bring them into the assembly and then modify their geometry. So that way you don't accidentally fall into these pitfalls. But now what we want to do is we want to select, in this case, part 7 at swing arm assembly 3, and we want to edit it. So we're going to edit this part. It brings us back into the part creation. We can expand it and we can edit sketch 1. Now, one thing you'll notice about sketch 1 is at the end of it, there's a little bit of an arrow there. If we right click on it, we can list external references. Now it tells us that feature sketch 1 is an in-context reference with the edge of the dog bone. So this is telling us that we have a link between the solid component in our assembly and the sketch that we created. Now obviously we don't want that, so let's delete all these components. Let's edit the sketch, delete everything here, and say OK. Now a good rule of thumb when you start creating this geometry is to hide anything that you don't want it to relate to. Because we can come in here and we can start applying relations between all this stuff, but I really don't want to accidentally apply anything. So we've deleted that sketch. We no longer have sketch 1 in our part. We're going to click this edit component, go back into the assembly. I'm going to move components where I think they should be. I'm going to extend the shock. I'm going to pull the swing arm all the way down. And as I do this, I'm starting to realize that the components aren't exactly where I want them. I need to move them around just a little bit. So the shock is going to rotate this way. The linkage is sort of over here. It's exactly where it needs to be. But we still need to relate back to this point on the swing arm. And you can see that it's not really lining up where it needs to be. So what I need to do is modify this dimension, which pushes it out a little bit. And that allows me to make this sort of linkage that I want. So that means I need to rotate this down just a little bit. And that puts most of it in line. All right, so now that everything is sort of in place, I'm going to go back into Edit My Component, Part 7. I'm going to edit the part, and I want to start a new sketch. Now, again, this is very important because it's very easy to come in and select the front plane of your assembly, or it's very easy to come in and select a plane that belongs to another component. Be sure that you're inside of the InContext part and that you select a plane that belongs to it. Now inside here, I'm going to start sketching sort of off in space. I'm going to draw 3 holes. I'm going to make all 3 of them equal because everything in here is 25 millimeters for some consistency, and I'm going to dimension one of them. Now I need to figure out how they relate to each other. I'm going to draw some construction lines from here to here to here, and then I want to apply some dimensions. Now as I drag this dimension away, I click the right mouse button to make sure I lock it so that I'm dimensioning the actual length of the line and not how it relates to our current coordinate system. I'm going to make this 50 millimeters. Again, right mouse button, and I'm going to make this 70 millimeters. And there's an angle between these. There's a slight angle here. I'm going to say 170 degrees. Now this is still not fully defined because it's not really located in 3D space at all. But that's okay. We're going to come back later and we're going to pop it to the origin. But really what I'm trying to do is see how close it is lining up with all my geometry. Now you'll notice when I drag it over, it tries to snap to this geometry. And again, that's very bad because when we move components, it's going to move with them. And that's not exactly what we want. What we need to do is hold down the Control key, and that'll override any of those persistent mates. It lets us get it pretty close, and I can take this one and get it kind of close. If you're having trouble lining it up, you can always take that point and you can fix it, and that allows you to rotate everything else around, hold down the Control key, and see where everything falls. So in this case, it looks like this is going to be closer to 65 millimeters, this one's 70, and there's a 170-degree angle between them. And then I'm going to select this point, delete the fixed relation, and now I know that the geometry I have here is good. I can start making the rest of the linkage in this case. So I'm going to take all 3 of these, I'm going to hit my S key, and I'm going to do an offset. I'm going to make sure that it's going a single direction, and I'm going to turn off construction geometry for the base because I need to keep that original geometry as a solid geometry. I'm going to offset at 15 millimeters and say OK. Then I want to start to take these construction lines, hit my S key, and we're going to offset those as well. In this case, these will be bidirection. Don't worry about construction geometry because it's already construction. And we're going to offset them 15 millimeters as well. Now inside here, I'm going to use my trim tool and use power trim to get rid of any geometry that's outside of the linkage area. I want to make sure these 2 end lines end directly at the link. Now we don't have to worry about trimming the inside stuff. We can actually use this sketch as is and say OK. So what we're going to do is we're going to extrude this and we're going to try to create the link as it would actually locate in the rest of our geometry. So I'm going to say OK for now. I'm going to extrude this, and I'm going to use my selected contours option to extrude all of this geometry as I'm selecting it. I want to leave the holes open, but I want to select this geometry and extrude it. My end condition is going to be mid-plane, and let's go ahead and extrude at 50 millimeters. As we're looking at this, you can see it's too wide for the shock, but it's not wide enough for this link. So let's get it close enough for the shock, which is going to be 30 millimeters, and then we'll worry about the width here after we take care of this. Let's say OK. We can come back and modify this by using the original sketch if we want, and we can use that sketch to extrude again. In the selected contours area, we're going to select just the boss around the middle section. Again, we're going to do mid-plane, and this time we're going to enter 100 millimeters. Say OK. And now as we look at it, you can see that it's going to locate between these 2 as well as fit between these. So now let's hop out of this back into our assembly, and let's go to the top of our tree. We're going to right-click on Swing Arm Assembly 3, and we want to hide the layout. Now the reason we want to hide the layout is because we want to go back in part 7, we're going to edit the part. Now, in your case, it might not say part 7. It will really depend on how many of these components you've created inside of your assembly. It might say part 1, it might say part whatever. So don't get too hung up on the name here yet. We'll talk about that in just a second. But now we want to go back to this sketch. We want to edit it, and we want to make sure that the geometry is located at the origin. We then want to take one of these lines and make them horizontal to make sure that we have a fully defined sketch. Very important because we don't want this to move around and change any of the orientations. We want it to stay completely fixed. You might be wondering, well, if we link it to that origin, it's probably not going to move anymore. Well, let's say, okay, let's look at this, and let's try to move it. Well, it's not moving, but there's a good reason. If we look at this in the tree, part 7, the first folder is called Mates in Swingarm Assembly 3. If we expand it, notice that there's an in-place mate. This is placed because we selected the front plane when we created our component. We simply need to right-click and suppress it. So now that it's been suppressed, this component can move around freely. Let's go ahead and do a quick save as, rebuild the document, and save it as Swingarm Assembly 4. Now you notice that we get this new warning. This warning was not shown in any of the other examples. Now it's telling us that we have features that are in context. Now with in-context parts, you have the option to save them internally to the file, or you can save them externally. By default, it's going to be saved inside of the assembly. So you see here we have this dialog box. It contains unsaved virtual components which must be saved, and that's this part 7 with the up arrow, Swingarm Assembly 3. We can save it internally, that way it's always inside of the assembly file, or we can save it externally and determine where we want to put it. Now in this case, I'm going to save it externally and we can rename it. It's currently called part 7, but I want to call this one linkage. And we can determine where it's going to go, same as assembly, specify path, internal to assembly. We're going to say same as assembly, say OK, and now it's saved external. It no longer says part 7 at assembly, it says linkage. But you also notice now there's a little question mark by it. The question mark is there because there are references. If we right click, we have some options to list external references. There's an out of context reference for a point, the origin of Swingarm Assembly. That was the origin where we located our sketch. It's okay, it says it's out of context, but it's able to solve. It doesn't give us any errors. It can still float around freely. So let's go ahead and save this, rebuild it, and that's a good place to end the in context part.